How do you find the surface area of a sphere? This video is for section 11-6 out of your textbooks. By the end of the video, you'll be able to answer the question, how do you find the surface area of a sphere? Here's a reminder of how your notes should be set up to take notes from this video. Remember, section and title goes up top. This is video title number 1. Then you'll have video title number 2, and there's no video title number 3. Make sure you write your notes in the right-hand column and complete your summary by answering the questions of the video titles. The radius of a sphere is just like the radius of a circle. When you have the radius of the sphere, it's going from the center of the sphere to the very outer edge of the sphere. And if you doubled the radius, then you would have the diameter. But we're going to need the radius in order to find the surface area of a sphere. If you cut a sphere right down the middle, oops, I did not mean to move that. I thought I hit this. There we go. If you cut a sphere right down the middle, you would create two congruent halves called hemispheres. Think about the Earth, or think about the globe. The equator cuts the Earth into the northern and the southern hemisphere. So here's the northern hemisphere and the southern hemisphere. Remember looking at different cross sections of different solids? Well, for a sphere, if you look at the cross-section formed, you will cut a sphere in half. What shape is it? Well, it's a circle, and this is called the great circle of the sphere. So if you cut a sphere in half, you'll have a great circle. Because the cross-section of a sphere has a great circle, we'll end up using the area of a circle to help us with the surface area of a sphere. So the surface area of a sphere is 4 pi r squared. Remember, we would just have pi r squared for just a circle, but because we're looking for the surface area of a sphere, we're going to multiply it by 4. So we have 4 pi r squared. Let's practice this formula with a few examples. Okay, here's example number 1. Go ahead and write everything you see on the screen, and then when you're ready to resume and follow along with my voice, go ahead and play the video. I'll assume that you paused and have all this information written down in your notes. The surface area of a sphere, let's go ahead and find it, and let's round it to the nearest hundredths instead of the tenths place. So the surface area of the sphere's formula is 4 pi r squared. We'll plug in pi to be 8 inches, because that gave us the radius is 8 inches. And then after we multiply everything together, we get 804.25 inches squared. Remember that this is the nearest hundredths position. This is the tenths, but we want the hundredths. And we put our correct measurements, inches squared, for the surface area of a sphere. Another example is for us to follow, but in this case, they gave us the diameter. Diameter is 10. So we'll cut that length in half and use 5 for the radius. We multiply and we'll get 314.16 centimeters squared. This type of problem is to remind you that radius is half the diameter. Some of you, when I corrected your quiz redos, you still plugged in the entire diameter for the radius, when the radius is half the size of the diameter. So what's half of 10? 5. Okay, I had to make some corrections on this slide because it didn't copy correctly. It made some few mistakes, but let's follow along and let's look at this example. First of all, I'll point out the two things that are wrong on here. It put a V here, but it should be pi, okay, from the surface area of a sphere. And then this inches should not be at the equal sign. It should be over here as inches squared, okay? So just, excuse me, ignore those two little pieces right there. Let's take a look at the example. The circumference of a great circle of a sphere is 25 inches. Find the surface area of the sphere. So we're going to use the circumference to help us find the surface area. First, we're going to use the circumference of a circle. So we have the circumference of a circle is 2 pi r, and we were told that the circumference of the great circle for the sphere is 25. So I'll plug in C to be 25, and we need to get the radius, because once I have the radius, then I can find the surface area of this sphere. Now I solve for r by dividing both sides by 2 pi, and now we get r equals 3.979. Notice how I kept a few decimal places, so that way my answer was as accurate as possible. Then I use the surface area formula here, so this is the big component. I had to use what was given to find the radius, and then now I can find the surface area. So I plug in the radius to be 3.979, and I square that. So this 2 should be right here for squaring that. And then I multiply it by pi and 4, and our answer would be 198.96 inches squared. So for this example, it didn't give me diameter, it didn't give me radius, but it gave me the circumference of the great circle. So I used that to find the radius and then use the radius to get the surface area of the sphere. Okay, so I made some corrections ahead of time. For this one, it's the same thing happened with the slide. So just go ahead and follow along. For this one, for this example, we need to find the radius. That's all we need to find. And we're given some information. We're given the surface area of the sphere is 804.25, and I want to find the radius. Well, since I'm given the surface area and I want to find the radius, I can just use the surface area formula of a sphere and I can solve for the unknown variable, which is r. Remember, we practiced this with some of the other solids that we found the surface area and volume for in previous lessons. So I'll substitute in 804.25 for the surface area because that was what was given. This is going to equal the equation. Then I'll divide both sides by 4 pi. Now I could divide it by 4, then divide it by pi, but why not do that at the same time? So divide both sides by 4 pi. Then I get 64 as my answer equals r squared. I'll square root both sides, which is not shown here, so I'll go ahead and write that in. Square root both sides, and now my answer is 8. So the radius is 8. I think it's really cool how we can take a bit of piece of information, just one little piece, and able to find a huge component of this sphere. Okay, here's our last example. Now we're being asked to find the diameter, and we're given that the surface area equals 100 pi. So once again, we'll use the surface area formula. We substitute in 100 pi for surface area equals 4 pi r squared. Divide both sides by 4 pi. The pi's will cancel out, so then you'll do 100 divided by 4 to get 25, and this equals r squared. Then you'll square root both sides. Let me do this in the blue color. Oh, there we go. Square root both sides, so r will equal 5, and since it asks for the diameter, I'm going to multiply that by 2 and get the diameter to equal 10. Now I want you to notice that you have to really know what the instructions are asking in order for you to solve for the right thing. If you would have just got r to equal 5, that would have been incorrect because it asked for the diameter. So this is our final answer right here. D equals 10. You have now seen a few examples on how you can find the surface area of a sphere. You also learned how to find diameter and radius, or even the surface area given the circumference or other pieces of information. So discuss those within your summaries. Bring all your questions to class.